So here's a little review on exponents and things that you might remember. We want to talk first about what an exponential expression is. Exponential expressions look something like this: a to the n. A is this, here is the base, and this n is of course the exponent. You can also sometimes see this, especially with variables in this form, where the variable is here still acting in place of the base. Here's the exponent, and here's the coefficient. We have a list of properties to deal with, or the ways that we add, subtract, multiply, and divide exponents. The first is the zero exponent rule or property. As long as a is not equal to 0, we have a to the 0 power is equal to 1. 0 to the 0 power is undefined. So some examples of how this might be used. Example, we might see something like this: 7x to the 0, where x is not equal to 0. X to the 0 should be simplified to be 1, and this entire expression simplifies to be 7. You have to be careful. Exponents only apply where they're closest. This 0 is only associated with the x and is not associated with the 7. You can contrast that with something like this: 7x all to the 0 power. This entire thing is equal to 1, because the 0 is on both pieces. Otherwise, exponents only act on the piece that's closest to it. The product rule says if I have a number a to the m times a to the n, a to the m plus n, I can add exponents as long as the base is the same. So examples of this: if I have x squared times x cubed, I go ahead and add these, combine, and have one base, 2 plus 3, and that gives me x to the 5th when I simplify. The quotient rule: a to the m divided by a to the n is equal to a to the m minus n. So examples, or an example, I have x to the 7th divided by x to the 5th, which is equal to x to the 7 minus 5. Again, one base. These two get combined into one base, and the exponents are subtracted, and I get x squared. There are 3 different power rules for exponents. The first, raising an exponential expression to another power, a to the m to the power of n. I multiply exponents there. So examples: x squared raised to the 4th power is x 2 times 4. People often get this confused with the product rule, so be careful here. Here there's one base, and it's being raised to an exponent, and the whole thing's being raised to another exponent, and I multiply exponents here. So that gives me x to the 8th power. The power rule when distributed over multiplication, so I have 2 bases here, a, b to the m power. I distribute this exponent to each piece inside. This piece distributes over multiplication only. So the example: xy squared to the 3rd power is equal to x to the 3rd power times y squared also to the 3rd power. Now this is an example of the previous power rule, so I'll get x cubed y to the 2 times 3, 6 here as my final simplification. And finally, the power rule is distributed over division. A over b to the m distributes similarly. So an example here. X over 2, all raised to the 4th power. This 4 will distribute to each piece. X to the 4th over 2 to the 4th. X to the 4th stays. 2 to the 4th is, let's see, 2 times 2 is 4, times 2 is 8, 16. Negative exponents are also some of the things that we'll see and need to be able to simplify. So in general, if I have a to the minus m power, this negative in the exponent serves to move this into the denominator. So example, 3 to the minus 2 power is 1 over 3 squared, which is 1/9. This is 3 times 3. Now, when the negative is in the denominator, this flips up into the numerator again. This is a to the n over 1 or a to the n. So similarly here, 1 over 3 to the minus 2 is 3 squared, which is 9 here. So these negatives in either the numerator or denominator will make it flip places. And with fractions, we have something like this. A over b to the minus n is equal to b over a just to the nth power. So an example, 1/3 to the minus 3 power is equal to 3 over 1 to the 3rd power. That's 3 cubed. 3 over 1 is just 3, and that's 27. Okay? So let's try to combine some of these rules and simplify this expression, a squared c cubed over b all to the 4th power. So let me just first write this down. Now when I simplify, I want to have only one base of each type, so I can't combine the a base and the c base, but if there were multiple a bases here, I could. This one, for example, I just need to distribute this 4 to each of these pieces. It distributes to this numerator to each of these and distributes to the denominator. So I'll get a squared to the 4th, c cubed to the 4th, over b to the 4th. This is a to the 8th, c to the 12th. This is using that power rule over b to the 4th. This is fully simplified. It doesn't contain negative exponents, and I only have one copy of each of the bases here. Simplify 3x squared to the minus 1 over z to the 5th. So here, this minus 1 on the 3 and x will effectively flip this into the denominator. So in the denominator, I now still have the z to the 5th. It's unaffected. But I also have the zx squared to the 1st power, z to the 5th. This raised to the 1st power won't change anything here. You can distribute it, but 3 to the 1st is 3. X squared raised to the 1st is still x squared. So I should get 1 over 3 x squared z to the 5th as my final answer here.